Hey everyone, so you clicked on this video because you want to understand permutations and combinations. Challenging concepts? Yes, indeed. A lot of people find these two concepts really challenging, but in this video, I'm going to make it really easy for you so that you don't have to worry about it and you can understand and even find some more challenging exercises to fully understand this concept. If this is your first time my channel, my name is Peter. I make math tutorials covering different math topics. So if this is content that you find interesting, please consider subscribing to the channel, like the video, and share this video with somebody who's going to find this content useful. Now, if you're ready, grab your calculator and let's get started. So permutations and combinations, these are concepts that help us count the number of possible outcomes with or without regard to order. So this is a very important distinction. If you are going to consider an order, that the number of ways you can count those objects or those things is gonna be different from if you don't regard the order of those things. And I'm going to explain this a little bit more later on in the video. These methods, the permutation and combination methods, counting methods, help us determine the total number of possible outcomes and hence be able to calculate the probability of events. If you have simple events, you can easily figure out the number of ways to choose those objects. But if it gets more complex, then you need some other methods that can help you do that. So the three methods that are typically taught are using lists, a tree diagram, and using mathematical reasoning. So under mathematical reasoning, we'll talk more about permutations and combinations. So the first method, organized lists. You're going to make a list of all possible outcomes that may occur. This method can be challenging. It can have difficulties because you might forget a particular outcome. Then that's going to affect the probability. Now, if you have simple events like tossing two coins or maybe rolling one die, the list will be short. However, if you have complex events where you have combined probabilities, combined events, then it's going to be really cumbersome and your list is going to be incredibly long and you might make a mistake. So here's an example of where we're tossing three coins, a penny, a nickel, and a dime. And these are all the possible outcomes. So you can easily come up with these 8 outcomes just by coming up with a list. But if you're going to be tossing, let's say, 5 coins or 6 coins, then you're going to see that it's very easy for you to forget a particular outcome. So the second method is the tree diagram method. And in this tree diagram method, we're going to use a diagram to organize all the possible outcomes using sort of branches to form a graph. This is a good method for visual learners that prefer drawing, but the downside is this tree diagram can get very cluttered when you're dealing with complex events. So here are 2 examples just for you to think about it. On the left side here, we have only 3 different events. 3 different events. We're tossing this coin 3 times, or even tossing 3 coins for that matter. And on this other side here, we have 1, 2, 3, 4, 5. We're tossing this coin 5 times, or you could think about we're tossing 5 different coins. And so the more complex the events become, the more cluttered that diagram is going to be. And sometimes it can be really hard to figure out what are all the possible outcomes. So after analyzing the first 2 methods, we come to this third method called mathematical reasoning to sort of go around the issue about the method being cumbersome and not being very reliable. So the mathematical reasoning helps to solve complex probabilities that are more efficient, that'll give you all possible outcomes. So there are 3 key concepts that we're going to look at, we're going to explore in this video. The first one being multiplication counting principle, permutations and combinations. There's going to be lots of examples here and exercises for you to try, so please make sure that you pay attention and follow along. So the first concept we're going to look at is called multiplication counting principle. So this concept, the first thing is the events that you're going to use have to be independent. When the events are independent, you can find the number of outcomes using the multiplication counting principle. And it works the following way. If there are m ways to make the first selection and n ways to make the second selection, then there are m times n ways to make the 2 selections. So you simply multiply the two ways that you can select those individual events. So here are two examples that we're going to go over. The first one says if you have 5 shirts and 4 shorts, how many different possible outfits can you make? So this is a pretty typical scenario where somebody goes traveling and they need to pack they need to pack enough clothes but have enough outfits on their trip. So how would you figure out all the possible outcomes? So you need to multiply 5 times 4 equals to 20. So you can come up with 20 different outfits with just 5 shirts and 4 shorts. The second example says a restaurant has 2 appetizers, 3 main course meals, and 4 desserts to choose from on their menu. How many different meals can you choose? Another typical scenario where somebody needs to figure out, if I'm going to go to this restaurant maybe 2 or 3 times, how many different ways can I combine the meals that I'm going to order? So how many different meals can you choose? So you're going to multiply 2 times 3 times 4, and that's going to give you 24. So they're going to be 24 different meals that you can come up with 2 appetizers, 3 main course meals, and 4 desserts. The third example says you are buying a new car that has 2 body styles, sedan or hatchback, 5 different colors, and 3 models, luxury, sports, or standard. How many different choices do you have? So we're going to start off with how many choices do you have for a body style? There are 2 choices. How many choices do you have for the colors? There are 5. And how many choices do you have for the model? There are 3. So when you multiply all those numbers, you get 30 different choices. It's also important to note that all of these events are independent of each other. When you choose a body style, it doesn't affect the probability of choosing a color or a model. So let's go to number 4. Colombian license plate has the format LLLNNN, where L represents a letter from the English alphabet and N represents a digit between 0 to 9. So it's really important to mention that the English alphabet has 26 letters. They don't use the Spanish alphabet, they use the English alphabet. So that's going to be really important in how to solve this math problem. So how many different license plates can exist in Colombia? So the first thing is to notice that how many choices do we have for the first letter? 26, because there are 26 letters in the alphabet. And then we're going to multiply that by another 26 and another 26. And then now we go to the numbers, the n. How many choices do we have for the first number? 10, another 10, and another 10. So these events here are all independent. When you choose the first letter, it doesn't affect the probability of choosing the second letter or the third letter. And the same thing with the numbers. When you choose the first number, it doesn't affect the probability of choosing the second number, and it doesn't affect the probability of choosing the third number. So when you multiply all those numbers, you get 17,576,000 different license plates. So these are way more than the number of cars that are in Colombia. Colombia has about almost 7 million cars on the road. So with this system of license plates, there are more than enough choices or different license plates that can be assigned to cars in Colombia without repeating. So permutations, this is the next concept, and a permutation is an arrangement of objects in a specific order. And this is another way for us to be able to figure out what are all the possible outcomes that we can have in a particular scenario. There is a very specific notation that is used for permutations, and it's written NPR. The N stands for all the possible objects, and R stands for how many ways that we want to arrange those objects. So we read this as the number of permutations of N objects arranged R at a time. So this is the formula. NPR equals to n factorial divided by n minus r in parentheses factorial. This exclamation mark, it's called a factorial sign, and in mathematics it's used to show a type of multiplication where the number decreases with each multiplication. So for example, if you have 5 factorial, it is 5 times 4 times 3 times 2 times 1. This entire calculation can be done on a calculator. But what's the connection to probability with permutations? Well, probability requires you knowing all the possible outcomes, all the possible arrangements. And so once you have those possible outcomes, you need to find the favorable outcome for you to calculate the probability. So this is a really important concept to know when you're trying to figure out probability. So let's go through some examples here where we're going to determine if this is a case that is a permutation or not. So the first example is, how many different ways can you arrange the letters A, B, C, and D? So remember, we want to know if they're different. So this is going to be a permutation. The only way that the order is going to matter is if they're different. So with 4 letters, the notation is going to be 4p4, 4 permutes 4, is equal to 4 factorial divided by 4 minus 4 in parentheses factorial. So like I mentioned earlier, 4 factorial is just 4 times 3 times 2 times 1, and then in the denominator 4 minus 4 is 0 factorial. In mathematics, 0 factorial is a 1. So in the numerator, you'll have 4 times 3 times 1, which will give you 24. So there are 24 different ways that you can arrange these 4 letters. You can confirm this answer if you use the multiplication counting principle. So how many ways can you choose the first letter? 4 ways. Because there are 4 letters, that means there are 4 ways to choose the first letter. Once you've chosen the first letter, the second letter, there are only 3 ways because you've already chosen a first letter. Third letter, there are only 2 ways to choose the third letter, and there's only 1 way to choose the final letter. So when you multiply 4 times 3 times 2 times 1, you still get 24. Let's take a look at the second example. How many different ways can you arrange 8 swimmers into a swimming pool that has 8 swimming lanes? So this is going to be a permutation because here we're looking for different ways. We care about the order. So the notation is going to be 8 permutes 8, which is equal to 8 factorial divided by 8 minus 8 factorial, and that is equal to, so 8 factorial means that we're going to multiply 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and then divide by 0 factorial. 0 factorial equals to 1. So using your calculator, 8 factorial is equal to 40,320. These are all the different ways you can arrange 8 swimmers into a swimming pool. All right, so here's the second set of examples. The first one says a rock band has 5 new songs and wants to put 3 of them on their album. How many arrangements of 3 songs are possible? So in this particular question here, we're trying to figure out how many different ways can you put those 3 songs. And so this is going to be a permutation. The notation is going to be 5 permutes 3. And so 5 factorial divided by 5 minus 3 factorial, that's going to be equal to 60. So there are 60 different ways that you can arrange the 3 songs on that album from the 5 songs. In the second question, we're told that an apartment complex has 15 parking spaces for 10 residents. How many possible arrangements are there? So we're trying to figure out how many different ways can we fit the 10 residents in those 15 parking spaces. So this is going to be a permutation kind of question. Once you've selected the first resident into that parking space, how many choices do you have left? And then so you keep on going down the line with how many choices are left. So the notation is going to be 15 permutes 10, and that is 15 factorial divided by 15 minus 10 in parentheses factorial, and that's going to be equal to 10,897,286,400 possible arrangements. So if you have a apartment complex and there are over 20 parking spaces, there are so many different ways that you can arrange the residents in those parking spaces. So the third concept is combinations. And combinations, this is where a selection of objects without regard to order. We don't care about the order. It's different from permutations. The notation for combinations is NCR. So N is the number of objects that you have, and R the different ways that you want to select those objects. So the formula is here, n factorial divided by r factorial times n minus r in parentheses factorial. So this formula is slightly different from the formula for permutations. So you have to pay close attention to how to use the formula. How combinations are different from permutations, let's look at these 4 scenarios. So number 1, qualifying in the top 5 in a race. So if you have a race and those races are in heats, normally they just take the top 5 races or the top 2 races. So whether you qualify in the first position or the second position, it doesn't matter the order you qualify to go the next round. That's a combination. Selecting people to be on a committee. So whether you are selected the third person or the first person, it doesn't matter the order. You'll still be able to serve on that committee. Number 3, the order in which we deal cards in a poker game. So if let's say you get a 3 and a face card, it doesn't matter the order of those cards, that's a combination. Shaking hands with people at a party, so it really doesn't matter the order at which you shake people's hands, that would be a combination. So let's take a look at the first example using these 2 questions to understand combinations. So the first question reads, there are 20 soccer players trying out for a team. How many 11-person teams can be chosen? So do we care about the order of how those 11 people that are going to be chosen? No. So this is combinations. So we're going to use the notation NCR to figure out how many 11-person teams can be chosen. So 20 combinations 11, and that's going to be equal to 20 factorial in the numerator, 11 factorial times 20 minus 11 factorial. And using our calculator, when you do that calculation, you get 167,960 different teams. The second question reads, in how many ways can you choose 3 types of cheese from a selection of 10 types of cheese? So do we care how we choose those 3 types of cheese? No, there's no order there. So it's going to be 10 combinations 3, so 10 factorial in the numerator divided by 3 factorial times 10 minus 3 factorial, and using our calculator we're going to have 120 ways to choose 3 types of cheese. So the second group of examples here also involve combinations, so let's take a look at them. A club has 24 members. The club has to select 3 members to leadership positions. In how many different ways can 3 members be chosen? So do we care the order of the 3 members? No, it doesn't matter. So this is combinations. So 24 combinations 3, 24 factorial in the numerator divided by 3 factorial times 24 minus 3 factorial, which is going to give us 2,024 different ways to have 3 members. And then so the next question is, in how many different ways can you select 5 types of flowers for a bouquet from a selection of 8 types of flowers? Do we care the order of those 5 flowers that are going to be selected? No. This is another combination question. So we have 8 combinations 5 is equal to 8 factorial divided by 5 factorial times 8 minus 5 factorial is equal to 56. So you have 56 different ways to select the 5 types of flowers. Well, there you have it. Permutations and combinations explained in one video. If you found this content useful, please like the video, subscribe to the channel, share this video with somebody who's going to find this content useful. And until next time, bye-bye.